In lesson 1 of chapter 9, labor market discrimination, the model presented here draws inspiration from Professor Walter E. Williams' 2017 essay, Minimum Wage and Discrimination. It's a pretty fascinating article. That's not too long. It's actually pretty short. That's Professor Walter Williams. He passed away a couple years ago. That article analyzed the impacts of government-imposed minimum wage on the typist labor market. The typist profession was once prominent before the widespread adoption of personal computers. And you can actually watch this video here if you like about typewriters in 1950 and how big an industry it was and how big a labor market was. It was so big that they had this world championship in typing. So this was an actual competition, right? That's how big typing was. You see these old typewriters with paper in them, right? The ensuing equations depict the labor market for both fast typists, 80 words per minute, and slow typists, 40 words per minute. This is the fast typist because it has a higher wage, and this is the slow typist, right? There's fewer of these fast typists who get paid a lot, and there's a lot more of the slow typists who get paid less, right? Okay, so what we need to do is we need to copy these equations into Desmos. Okay, and I'm trying to figure out why this one's not working. There it goes. Now it's working. I'm going to create 2 of these Desmos sheets. One for slow typists, one for fast typists. Okay, that's a little better. Then we got to do the same thing over here. That's pretty good. So now we can use the diagrams here. We can use the 2 diagrams here in Desmos to compute the equilibrium employment level and the wage rate, right? So for the slow typist with that labor demand equation, right? And this labor supply equation, we have an employment level of 64, right? So we have 6,400, right? 6,400, right? 6,400. And then they're getting paid $13.71 an hour. Okay. Now, what about the fast typist? The fast typist labor demand equation right here, and the fast typist labor supply curve right there. There are 3,200 fast typists, and each of them are getting paid $20.40 an hour, right? Now, the intercept of the labor demand for slow typist right here, the intercept for the slow typist implies that firms are willing to pay up to $24.59 per hour to hire the first slow typist. That's what that implies, right? The intercept of the supply of slow typist, which is 5.39, right? That value right here. The intercept of the supply of slow typist implies that a slow typist has a reservation. There's at least one slow typist with a reservation wage equal to $5.39, right? The reservation wage of the 6,400th typist, this one here, the reservation wage of the 6,400th typist, right? Because remember, these are in 100, right? Well, that is $13.71, right? $13.71. And firms are willing to pay that last slow typist, the 6,400 slow typist. They're willing to pay that worker at most $13.71, right? Now we got to calculate the total surplus. And the total surplus is this triangle here, right? So the height of the triangle is the difference in the intercepts, right? So the difference in the intercepts, 24.59 minus 5.39, right? That's the height of this triangle. The width of the triangle is the employment level, 64. Now, this is the area of a rectangle that would come over here and then down, right? And then over here. A triangle is half the area, so we got to divide that by 2. So the total surplus in this labor market is $614.4. Now, the intercept of the labor demand for the fast typist, 2584, right? That's the intercept of the labor demand for fast typist right here, right? Firms will to pay up to $25.84 per hour to the hire the first fast typist. The intercept of the supply of fast typist, 984, implies that a fast typist, at least one, has a reservation wage equal to 984, right? Now, the reservation wage of the last fast typist, the last fast typist, is a 3,200th typist, right? Because there's 3,200 of them, right? Or 3,200, right? So the reservation wage of that last fast typist is the market wage, which is just above 20, right? $20.40. Firms will want to pay that last fast typist hired a wage rate no greater than the market wage, right? Now we got to calculate the fast typist total surplus. Again, it's the difference in the intercepts times the employment level divided by 2, right? So the difference in the intercepts, 25.84 minus 9.84 times the employment level. The employment level is 3,200, but in our model, 32, right? Because E is in hundreds. And we're going to divide that by 2. So 256. I'm going to edit this so this says $100 and this says $100. Okay, so I just added the 100 there, right? And 100 there. Okay, now the total surplus is the sum of the two, right? We got $614.40 plus the 256, right? So total surplus in both markets. Okay. Now, suppose fast typists are perfect complements with slow typists, because typing service firms offer 2 types of services. They offer an expensive express service performed by fast typists and inexpensive slow service performed by slow typists. Suppose also there are 100 identical firms in this market. Firm R is one of these firms. 3 of its isoquants are shown below in the diagram. Now, there's infinite many of these isoquants, right? There's infinite many of them. I'm just showing you 3 of them. Given the labor market equilibrium employment levels, firm R hires what? Now, again, there's 100 identical firms, right? And we said E was in hundreds, right? So this is actually 3,200, right? So 3,200, there are 100 identical firms. They're all going to hire the same number of employees because they're identical, right? So if I divide this 3,200 by 100, I get 32. Each of the 100 firms hires 3,200 fast typists, resulting in 3,200 in the market, right? And then remember, E is in hundreds, right? There are 100 identical firms. So the market equilibrium is actually 6,400. We're going to divide the 6,400 by 100 and we get 64, right? So each firm, each one of the firms, identical firms, and there are 100 of them, each is going to hire 32 fast typists and 64 slow typists. At 32 fast typists and 64 slow typists. So altogether, they produced 9,000 type pages, which cost the firm what? The market wage of the slow typist was 13.71, right? And each firm hires 64 slow typists. The market wage of fast typists is $20.40. And each firm hires 32 fast typists. That labor will cost the firm $1,530.24. Now, this line here is an ISO cost. At every point on this line cost the firm $1,530.24. This line intersects this isoquant at the corner. If the wage rate of fast typist increases to $30.60 per hour, what's going to happen here? If the wage rises $30.60 for the fast typist, what's going to happen here is, let's look at the slope of this ISO cost line, right? I have the slow typist on the y-axis. I got the fast typist on the x-axis. So the slope of this black line is the fast typist wage, $20.40, divided by the slow typist wage, which is $13.71. So the slope here is 1.48, roughly 1.5, right? That's the slope. It's -2, right? It's negative because it's downward sloping. Okay. Now, if the wage rate of the fast typist increases to $30.60, I'm going to replace the 2040 with that, $30.60. The slope is 2.23. So the line, the ISO cost line, will be more vertical, right? It'll be steeper because the numerator wage, which is the fast typist wage, that has gone up to $30.60, right? Now, how much does that cost the firm? So all we have to do here is we have to change fast typist wage to $30.60, right? And that's going to cost the firm $1,856.64, right? It's not going to change the optimal solution because all we're going to get is a rotation of this ISO cost line, right? We're just going to get a rotation of it. It's going to rotate through that black dot. So R is still going to hire 32 fast typists and 64 slow typists to minimize the cost of producing the 9,000 pages, right? This was the old but ISO cost line right here. The black line is now the new ISO cost line, right? It just got steeper, right? It just got steeper. That's all that happened. So what happens? The fast typist wage decreases to $14.69. Well, if it drops to $14.69 and we hold everything else constant, what happens to the slope here? The slope of the line drops to 107. And the cost drops to $1,347.52. So what's going to happen is this black line is going to come down below this gray line. It's going to rotate through this black dot, right? It's going to rotate the opposite direction. So the firm will still hire the 32 fast typist and the 64 slow typist to minimize the cost of producing the 9,000 pages, right? Got flatter because the slope is 1 now, right? In all three scenarios, this black dot is the cost minimizing level of employment, right? So no matter how much the hourly wage rate for fast typist deviates from the market wage of $20.40 per hour, hiring 32 fast typists and 64 slow typist minimizes firm cost. Again, because they're perfect complements, right? Fast typists and slow typists are perfect complements. Firm R's revenue at this point equals what? So if the market price, let's go ahead and hit enter here. We're back to the original ISO cost line with the wage of $20.40 for $20.40 per hour for the fast typist, $13.71 for the slow typist, right? So we're back to where we were initially. And the slope is back to $20.40 per hour, right? So the slope is back to 1.49, almost 1.5, right? So if the market price of type pages is 18 cents, right? Firm R's revenue is what? Well, we got 18 cents per page, and we're producing 9,000 pages, right? 9,000 pages. Our revenue is $16.20. And the cost, we're going to subtract firm R's cost from the 1620, and it results in an economic profit of equal to what? So we got the 1620 minus the cost, back to original wage levels, $1,530.24. So we have an economic profit of $89.76, right? The economic profit here at this point is $89.76 because the revenue of producing 9,000 units is $16.20, and the cost of 32 fast typist and 64 slow typist, the cost there is $1,530.24, right? So our costs are less than our revenues, and we have an economic profit. Suppose the lower paid typists are black because they had only one typing class in high school, because they only had one classroom with typewriters in it. It was underfunded. And the higher paid typists are white because they had typing classes every semester of high school because they had lots of classrooms filled with expensive typewriters. The wage differential would equal $6.69, right? $20.40 minus $13.71 results in a wage differential of $6.69, right? Suppose the owner of firm R does not want to hire black workers. He is considering hiring just 32 black typists. If he does that, firm R could hire what? Holding its costs constant. Its cost, if you remember, its costs were what? Let's go back and calculate the cost. Its costs were $1,530.24, right? Anywhere along this ISO cost, it cost the firm $1,530.24. So if this owner of firm R does not want to hire black workers and only hires 32 black typists, if he does that and we want to hold his cost constant, that would put the firm down here, right? At this point, 54 workers and 54 white workers and 32 black workers. So we'd be at this point here, right? Because we're holding cost constant. And this is called the ISO cost line. ISO meaning the same, right? So we're going to end up at this point here, 32 black workers and 54 white workers. So we're at this point here, right? However, that reduces firm R's output, right? The firm R's output goes from 9,000 down to 4,600, right? Because this is the output, right? So we have output of 9,000 here, and we got an output of 4,600 here, right? So the output is only 4,600. Type pages per hour. What is revenue? Well, remember the price was 18 cents per page, right? So what happens to revenue? Now we're only producing 4,600 pages. So revenue's $828. And what is profit now? Costs are still $1,530.24. The revenue is $828. So profit is negative 702.24. They're making an economic loss, right? Rather than have that occur, the owner of firm R chooses to hire what? They'll choose to hire 32 white typists and 64 black typists to minimize its cost and generate economic profit of. So it wants to go back to this point, right? The profit motive is so strong that it overcomes the discriminatory practices of the firm. They're more interested in profit than discrimination, right? If this point were profitable, they would stay at this black dot, but it's not. So what this firm does is, even though they're not colorblind and don't want to hire black workers, what they'll do is they'll come to this point here anyway, because they're making a profit here. If they stay here, they're going to go out of business, right? Also, it's likely that their competitors are hiring black workers, right? So the firm will slide back up to this point here, right? Maybe it tries this out for a month and then goes, man, discrimination doesn't pay. So it slides back up to this point, right? So when it slides back up to that point, it's going to end up hiring 32 white typists and 64 black typists, even though it's a racist firm and doesn't want to hire 64 black typists, right? So the economic profit is what? We're back to 9,000 units. So our revenue's back to 1620. And our costs that have been held constant because we're sliding up and down this ISO cost line. So the economic profits turn, and the firm's making $89.76 per hour, right? Okay, and that results in the new equilibrium. It started here, slid down here due to discrimination. And when the firm realizes that point is not profitable, it immediately reverses course and comes back right up here. Now, what I want you to do is I want you to read this article and then find the answers in the article. These are excerpts from this article. So read this article and find the words or phrases that go in these boxes. And now, remember, you only get 2 attempts per box. So you got to be really careful on that, right? Unless you want to redo the whole problem.